I ever wrote a program to generate music, I would just make it open source and talk about it and make a video about it and, put it all out there. So that's what this video is. Hello everyone and welcome. A little bit ago, I released a video on my channel. It's called something like 5 hours of programmatically generated piano music. And that's exactly what it is. It's 5 hours. There's a lot of different songs that are each the exact same length. It's piano music, but it's all been programmatically or algorithmically generated. So in order to make that, I actually wrote it myself. I wrote a program. It's all in Node.js or JavaScript. And that program is responsible for generating music. Or more specifically, generating MIDI, generating the notes that would go into music. I then take that MIDI information, put it into my music processing software, and make it sound nice. And by make it sound nice, I mean use a real piano patch, put some reverb on it, put some compression on it, and adjust the gain so it basically sounds like it's been, decently mixed and mastered. It's nothing perfect, but, makes it sound realistic, something like someone would actually play. So I wanted to go over basically the process of that, how I did that. I'm actually going to do a deep dive into the code, so you'll be able to see the code that makes it. It's surprisingly not a lot of code, just a couple hundred lines of JavaScript, and with that, I'm able to generate music anywhere from 20 seconds long to a 10-hour track if I wanted to. So here's a fun story for everyone. I had a dream a couple months ago. It's so weird, but I had a dream that I did exactly this. In my dream, I wrote a program to generate music. I generated a lot of music. I had this endless stream of music from this program that I wrote. So in my dream, I made a YouTube stream that was just a continuous stream of algorithmically generated piano songs under the guise of relaxing, calm piano or whatever. And then of course, as part of that dream, my YouTube channel got really big and I was like, oh man, this is awesome. But then I felt this immense guilt because I was like, oh no, I haven't told anyone I'm actually algorithmically generating the music. They're gonna think I'm actually writing it when they find out I didn't actually write it. They're gonna think I'm a fraud. It was weird, it was bizarre. I felt this weird guilt in the dream. And the reason I say it's bizarre is because when I woke up, I was like, it's not something I would feel guilty about because I would just be completely upfront about the fact that it was programmatically generated. If I ever wrote a program to generate music, I would just make it open source and talk about it and make a video about it and, put it all out there. So that's what this video is. That's where the idea for this video came from. It took a couple of weeks, but I sat down, didn't even know if it would really be possible, but I started writing a program to generate piano music. And when I say started, I mean, well, I actually finished and it's up, and I'll link to the video in my description. You can see it. It's like a 5-hour generation of just algorithmically generated piano music. It's pretty nice. It sounds cool. It's something you just put on in the background and kind of just space out to. So yeah, spoiler, it worked, and the program exists. You can go download it. I'll link all of it in the description. But yeah, so I kind of wanted to walk through the technical process of that, go into the specifics of it, and basically how I approached this problem and how I wrote this program. So to get started, I do have a slide deck here. It's only 3 slides. It's not going to be a boring PowerPoint, I promise that. It's just meant to give a visual understanding of how I broke this problem down in my head before jumping into the code. So kind of give think of this as the whiteboarding before reaching towards actual code. So before we get too far into this, I want to take a moment to thank today's sponsor. Nobody. I don't have a sponsor. I'm a small YouTuber. If you want to sponsor me, that'd be awesome. Reach out to me. I will take this moment to plug my merch though. Bam! Dave Eddy merch. It's a reality. It exists. I have a website. I'm going to link it below, daveeddy.com/merch. I have a whole bunch of different t-shirts designs. Pretty cool. Check it out. If you like this content and you want to support the channel, just hit like, subscribe, share it with a friend. That's all I ask. Anyways, back to the video. So basically, the first thing I ran into, the first issue or the first thing I had to think about was, what makes a song? If I'm gonna generate a song, I need to break a song down into its parts. I need to break it down to its most indivisible unit and then start generation from there. So break it all the way down, have something generate that, and then build it all the way back up into a song. So take my conceptual understanding of a song, bring it down to its base notes, and then from there write a program to build those base notes back up, and then put it all together and make a song. So to do that, I broke down a song into these parts right here. So an example you could see in the first visualization, we have intro, verse, chorus, etc. This is kind of common with music. You'd have an intro, a verse, a chorus, a verse, a chorus, maybe a bridge, maybe an outro, all different things like that. I am calling these sections. An example of a section would be an introduction, or a verse, or a chorus. Each section would have its own pattern of notes, and in that pattern would be a bunch of bars. So jumping down to the next part in the visualization, we have, okay, what makes a section? Well, a section is constructed of bars, and a bar is a musical term. I'm borrowing from that. Let's just assume a 4/4 meter here. A bar would have 4 beats in it. Now, a pattern, like an intro, could have multiple bars inside it, one or many. In my code, I have defaulted to 8, but that's a customizable setting. When I say 8, I mean 8 bars per section. So an intro would have 8 bars. There would be an 8-bar verse, an 8-bar chorus, etc., all customizable. So now we have to talk about, okay, what's in a bar? We have 4 beats. What makes up a bar? Well, a bar is just made up of notes. Those notes could be however long. They could be 1 beat long. They could be, an eighth note, a quarter note, a half note, all sorts of things like that. And there's nothing we can do past that. There's nothing smaller than a note. We have a note, which is the, indivisible unit of music. So with notes, we can build a bar. With bars, we can build a pattern. And with patterns, we can build a song. So to visualize that differently, I've taken this example right here. You can see if we just focus in on the introduction is made up of a series of bars. And if we focus in on a specific bar, the bar is made up of a series of notes. That's it. So now to work our way backwards, when it comes to actually generating these, we're gonna have to start by generating notes to fill bars, bars to fill patterns, and then smush patterns together to make a song. Simple enough, seems straightforward conceptually. We can see how that actually looks once it gets time for the, code. One final thing to think about, for a piano song, you would have a left hand and a right hand. You would have the left hand kind of playing some sort of rhythm, something to kind of just keep you going, and the right hand might be doing some sort of melody, some sort of thing that you would actually think about. The left hand sort of grounds the whole song, and the right hand sort of is like something you might want to focus on. Very loose, I'm using very loose definitions here, because again, I'm just generating these notes at random, so to use the left and right hand doesn't really make sense. A computer's not using a hand to play these. This is just sort of a way of conceptually thinking about what the goal is of these 2 tracks. So to add more terminology here, we have 2 tracks. We have a left-hand track and a right-hand track. And the cool thing about this is we can just generate an entire song for the left hand and then generate an entire song for the right hand, put them together, and those 2 songs, if played at the same time, will just be one song. So all that stuff we learned about patterns, notes, and bars, we just do that whole process for the left hand, that whole process for the right hand, and as long as all the patterns are the same length and the sections are the same length and the patterns are in the same order, i.e. intro, verse, chorus, bridge, stuff like that, it should all work out. Should. We'll see if it does. So yeah, let's look at some code. All right, so we are in the music generator directory. Again, this repository, all this code will be available online. You can clone it yourself and look at it. All right, so there are 2 files that we care about, 2 files of note here. And those files are in the bin directory and the lib directory. The bin directory houses music generator. This is the entry point to the code. This is something you can call on the command line. In fact, you can even give it a -h for help, and it would give you a nice little help screen. All this is responsible for is taking in command line arguments from the user, putting them in some sort of format that all of the logic inside /lib/song can deal with. So the bin file is actually very small. The heavy lifting is done in the song.js file. So let's jump into that. So we have song.js here. If we look, there's only 483 lines of code here, so it's less than 500 lines of code. So yeah, if we just start at the top, we can go over some of the basic ideas that I took on here. To start things off, we have to think of a piano, okay? So a piano has 88 keys. There are 88 possible different notes. Now within those 88, there are octaves. So every 12 notes is an octave. After that, it repeats. It's just a higher pitch than the note you heard before. So there are 12 unique notes, but 88 total. So we need to break this down to something that's more manageable. So the first thing we do here, you can see this code right here. This is responsible for looping from 0 to 88. So this loops every possible note. And then I do some clever trick here. I modularly divide it by 12 because there are 12 unique notes. And then I only keep the notes that are 0, 2, 3, 5, 7, 8, or 10. And the spoiler alert is in the variable name. I push them into an array called all minor notes. So I just went through the minor scale there, very simply. Just loop through the scale, and any note that was in the minor scale, we kept, and any note that wasn't, we threw out. So immediately, this code is extremely biased. This music generation will only generate things in a minor scale. Simple as that. No dancing around, it just does minor scale. It doesn't even try to do major. There's no tricky machine learning going on here. This is just basic algorithmically generated music. Now before we go on, I want to talk about the left hand and the right hand. I have a different approach for generating notes for the left hand than I do for generating notes for the right hand. To generate notes for the left hand, I wanted it to be very simple patterns. To do this, I actually just coded in a bunch of very, very basic left-hand patterns. It's kind of like cheating, but I put in a bunch of very simple left-hand patterns. So basically the code can only choose from this set array of patterns. The patterns are very simple. So if you look at the code, we're going to skip over note types for now. I have this variable called left-hand patterns. So if you look at it, it's an array of patterns, and each pattern, let's start with the first one. This has a duration of 1. It's actually kind of backwards, but that means it's a whole note and it starts on interval 1. We are indexed at 1, not 0. So this just means for this left hand, it's like someone hit the root of that note and just held it for 4 beats. That is what that first pattern is. Each pattern here is randomly picked, so there's an equal chance of any one of these patterns being chosen for any bar. Don't want to jump too far ahead, but each pattern is very simple. The next pattern down, these are half notes, and the pattern is the 1 and then the 5. This is a perfect fifth interval, so it's just 2 notes of 1, 2 notes of 5. If I were to play that, it would sound like very simple. The next one is 1 and 8. Same thing as the other one, just that's what it would sound like. We have 1, 3, 5, which is a quarter note of 1, a quarter note of 3, and then a half note of 5. So of course, that was in the major scale. In this example, it would actually be in the minor scale, but that's just the idea. And then we have the same thing, but instead of 1, 3, 5, it's 1, 5, 8. If you're a guitar player, you'd probably recognize that as a power chord. And then this one is just 1, 5, 8, 5, which is... So very, very simple, very unassuming left-hand patterns. Now, let's talk about the right hand. So the right hand's slightly different. The right hand is actually where the fun is. It's all randomly generated. What that means is the right hand will start at the root of whatever we're on. So if the song is an A, it will always start on an A, but then it will go randomly up a certain amount or down a certain amount and pick a note within that. And on top of picking a note within that, it will pick a random duration. And how does it pick those? Well, it picks them out of this variable right here, note types. So you can see I've notated what they are. This is a whole note. It has a duration of 1, and it has a 10% chance. So when it randomly generates a right-hand note, there is a 10% chance of generating a whole note. There is a 30% chance of generating a half note, a 20% chance of generating a quarter note, 20% of generating an eighth note, and a 20% chance of generating a 16th note. I just realized I had a typo there. So, simple enough logic. It has a range of possible notes for the right hand, and it will randomly pick a note within that range, and then randomly assign it a duration based on that note types variable. So you have the left hand, which will randomly choose a bass for each bar. So it has a section of notes it can choose from. It always starts at the root, which might be A, but then it might go like A and then to a C and then down to a G or something. But it will always choose one of those patterns. The right hand patterns will always be randomly generated, and they will reset every section. So it will randomly generate notes to fill, let's say, the introduction section, but then when it gets to the end, it will make sure the last note stops at the end, and then the next section will have a right note start there. So you won't ever get out of sync. So let's jump down a little bit. All right, so this function right here, this is the generate function. This is sort of the entry point to this module. This is the function that's responsible for going from 0 notes to an entire song worth of notes. And how it does that, it's actually really simple. I mean, you can see the code right here. We have an array called left-hand notes and an array called right-hand notes. They are empty. And then by the time you get to the bottom of this function, we have a song variable that's made up of all of the left-hand notes in a new track and all the right-hand notes in a new track. So right here, this is the main flow of the program. So from the top, we have no notes. At the bottom, we have all the notes. The whole song is generated. So now let's figure out how that's done. So the first thing we do here is we take the pattern. Notice the generate function takes a pattern argument, and then we split it. This is a little JavaScript trick. I mean, this probably works in other languages, but this takes a string, splits it on nothing, so it just makes an array of every character in that string. So let's talk about patterns. The slides that I showed before, patterns had names like intro, verse, chorus, outro, something like that. Well, to this program, it doesn't care what you call them. It doesn't actually even want it to be human readable. It just takes whatever character you want to give it. You could call a section any character you want under the sun, as long as it's just one character. So for an example, if we went intro, verse, chorus, outro, we could say that's A, and then B, C, B, C, and D. A little confusing, I'll explain it. I'll show an example. So if we were to, I have to save it because I had a typo. Cool. All right, so I tried to run music generator, it gave me an error. The reason it gave me an error is because it expects the pattern string that I was just talking about. So let's give it a simple pattern string. Let's do intro, verse, chorus, outro. So we'll call intro A, we'll call verse B, we'll call chorus C, the verse is B, the chorus is C, and the outro is D. So what this means is there are 4 unique patterns this program must generate. It must generate a pattern for A, a pattern for B, a pattern for C, and a pattern for D. However, those patterns show up 6 times in the song. Only 4 unique patterns need to be created, but then they're smushed together into a 6-pattern song. So there will be repeats. So you will recognize an 8-bar pattern of B, an 8-bar pattern of C, and then you'll hear B and C again. This kind of makes the song so it doesn't just meander for 3 minutes. This makes it so a song actually kind of has some cohesion to it, so you hear the same things over and over again. These patterns will just be exact. Now, if I were to generate this, it would actually just flood standard out with garbage. So let's call this simple.mid, and it outputs some debugging information, but bam, now we have a MIDI file. I'll get back to that in a second. Let's go back into the code before we actually start listening to these MIDI files. All right, so now that we understand what a pattern is, this code is responsible for looping over every possible pattern. And you can see the first thing to do here is if we already have the pattern, then we skip it. So what that means is we just go through and generate each pattern. So for an example, if we were going through the string A, B, C, B, C, D, we'd first generate a pattern for A and we'd save it. We would then go generate a pattern for B, we'd save it. We'd generate a pattern for C, we'd save it. We would be asked to generate a pattern for B, but we already had one, so we would just move on. C we already had, we move on. D, we generate a pattern. So when this is done with that 6-character pattern string, we would have 4 new sections already created by this function make section. Don't worry, I'll go into what that function does. The next thing we do is we loop through each possible pattern. So this was the original pattern string we got, and then we just construct the notes based on all of the existing patterns we generated. Basically, this just smushes the patterns we created into the right order to match the original pattern string order, and this creates the song. Very simple. So let's jump into the make section function. The make section function, very straightforward. We create an array of left-hand notes, an array of right-hand notes. We go through and we calculate how many bars there need to be. Now remember I said those were customizable, so by default it's an 8-bar section for the right hand, but it's a 4-bar section for the left hand. That means the left hand repeats every 4 bars. So how this works is in order to make a pattern that satisfies an 8-bar section and a 4-bar section, we have to calculate the least common multiple between 4 and 8. Luckily that's an easy thing to calculate for 4 and 8. You can get really complex if you wanted to. But basically what that means is a single section, so like an intro or a verse, will be 8 bars long. And for the right hand, it will be all unique notes for those 8 bars, but for the left hand, it will be 4 bars and then a repeated 4 bars. So it kind of just makes it very simple to follow when you're listening to it. The left hand doesn't go too far off. You kind of get grounded in the same chord progression. To jump into that, where's the actual meat of the code? Well, it's right here. We have a make left hand function and a make right hand function. Let's start with the make left hand function. This one is not too difficult because the patterns are already pre-generated. So what we have to do is we have to figure out what root note we should use for each pattern or for each bar. So let's say we're going to be generating 4 bars here. Well, the first bar, we should always make the root of the song that we're in. Each song has a root by default. I have it set to A, but you can transpose it to be anything. So right here, we just manually push the root right in, right first. The root is always first. So then we start at 1, we count up to the number of bars there are, and we push randomly a new root. This could potentially repeat. You could get a left hand where the bar just, the chord progression goes from A to C and then C and C. Like that's technically possible. It doesn't sound bad, but that's just a possibility. One thing to note here is the second note of the minor scale does get filtered out. And the reason I went with that is because if you get the 1-3-5 pattern on the second in a minor scale, this is just some music stuff, it's not gonna sound good. Most of the time it sounds good, but on the second, it's not gonna sound good. Okay, so when we get to this point in the code, we have the roots figured out for the left hand. Again, this is gonna be 4 bars that repeat, so we have 4 root notes. Let's say, for example, we have A, C, D, E, something like that. Well, we know the roots, but we have to figure out the patterns now. Remember those left hand patterns from earlier? So what we do is we just randomly pick one. You can see this code right here, random element from array. That function does exactly what you think it does. You give it the array of left-hand patterns and it just, bloop, there you go. Here's a pattern. It's just randomly generated and it just gives it to you. And then from there, we just take care of if there's any sort of transposition. So when you run the program, you can specify what key you want it to be in. But this program, the way this program works, it assumes everything's in the key of A. You can just give a -t transpose argument and it will cause it to go up or down. But this code thinks of every song as being in the key of A. And then from there, we have all the notes in the pattern. So we just push the notes to the array of notes. And there we go. That's how we went from a pattern to a section to a bar to a note for the left hand. Little note here, this velocity uses a function called getVelocity. That just randomly assigns a number between a range. The velocity is how hard the note is hit. So if I were to just lightly hit a key, pretty weak. If I were to slam on it, it gives you a different sound. The velocity is just how hard it was slammed. It's a number between 0 and 127. So the next thing we can jump to is we know how the left hand is made. We can now go to the right hand. So again, the right hand is different. We're not using predefined patterns. We're generating all of our own patterns to go into the bars. So in order to make a right hand, we have to do, well, something interesting. So the first thing the make right hand function does that's of a note here is a function called make melody. I should probably rename this function. It should probably be called make rhythms because that's actually what it does. It does not generate any of the note by pitch, so it doesn't care if they're an A or a B or a C. It doesn't care about any of that. It just generates note lengths that fit into the pre-described bars. So if it's like an 8-bar section, it will generate enough notes to fit exactly 8 bars and not go over. That's the goal of the make melody function. So the make melody function goes through and it figures out what note type to use. Now, if you remember, there were the note types at the top, like a whole note, a half note, a quarter note, and they each had a chance of being generated. That's what this code does right here, is it goes through and generates a number between 0 and 100 and then figures out what note it should be based on the number. So it figures out what note length to make, and it keeps adding them to an array. This is just basically a while true. What we do is we just keep filling this array until we hit those 8 bars. And then the way we know we're done from this is once the sum of all the notes we've created plus the notes we want to add is greater than the number of beats we could possibly put in the bar. Basically, we keep going until we overflow, but we don't actually push the overflow on. We just sort of push on the smallest note at the end, and we set the volume to 0 on that. So what that means is we just keep adding notes until the last note we're going to add would have caused it to overflow. We don't add it. We add a smaller note that fits comfortably in that position. That's all this function is responsible for doing. So when we go back to the make right hand function, we have this melody of just rhythm note durations. Now we need to actually apply pitches to them. So to do that, we generate a pitch for the note. We loop over every possible note. So you can write here durations.forh. We're looping over every possible note, and then we generate a new pitch. Now the point of this while loop is that we don't keep generating the same pitch too many times in a row. Because I've gotten unlucky where the same pitch was generated 5 times in a row, which is kind of lame. So I made a customizable max pitch in a row. I have it set to 1, but you can set it to whatever you want. And this will just try to keep regenerating the note if you get too many in a row. That's all the purpose of that while loop is for. So now we have a note. Just like when we were creating the left hand and we ended up with creating a note, we were creating the right hand and now we ended up with these notes. So we just push this note into the notes array and we return that notes array. So if we go back to where this was called, you can see that all make left hand and all make right hand do is just make a ton of notes. That's their goal. That's what they do. They make all the notes that go into a left hand and a right hand. And then the final thing we do before we smush it all together into a song is we filter out dissonance. It does more than filter out dissonance. I came up with this idea later as I was iterating on it because some of the songs just sounded terrible. The reason they sounded terrible is because the left hand and the right hand would sometimes collide with each other. If the ranges were overlapping, the left hand and the right hand might play the same note at the same time, which would cause it to sound twice as loud. On top of that, the left hand or the right hand might play notes that are right next to each other on the scale. So you could just be hearing a nice song like, you would hear something like that. And it just, the moment you heard that, it took you right out. You were just like, oh, this sounds terrible. Like, I think a human being would have avoided that. So I just filter out all that possible dissonance. And the way to do that is, it's kind of complex. I won't go into the details of this code, but basically the left hand is like its own song. The right hand is like its own song. That stinks, because what I have to do is I have to kind of just start from the beginning of the left and right and work my way forward and then figure out if there are any collisions in notes. It's kind of an annoying algorithm to write, but long story short, the part of the code that matters is right here. I calculate the difference between the pitch in the left hand and the pitch in the right hand, and if the difference is -1, 0, or 1, I filter it out. So if the difference between the two pitches is -1 or 1, that means they're right next to each other on the piano. If the difference is 0, that means they're on top of each other. There is no difference. They're both going to play at the same time. So regardless of if they're right next to each other or on top of each other, just get them right out of there. They don't need to be there. Just replace one of them with silence. In fact, you can see right here, I replaced the right note. I set the velocity to 0. So it's the equivalent of the right note just not being pressed. Why the right note wins and not the left note? Arbitrary. I could have picked the left note. There's no rhyme or reason to that. Just a biased decision by the creator of this code, me. So yeah, that's it. That's kind of the deep dive into this code. Like I said, it's not too difficult to understand. Once I had broken down sort of the guts of a song, it wasn't too bad to go through and start generating something that was workable. So yeah, I guess let's have some fun now. Above, we already generated that one thing called simple.mid. So what we can do is we can go over to Logic Pro. This is the program I use to work on music. This is a blank new project with just one instrument selected, just a grand piano. And right here, I have a folder of MIDIs. There's no MIDI in here. Oh, of course, I didn't generate in the MIDI folder. I generated outside of it. That's cool. So here's the simple.mid that we generated earlier. So let's go ahead and hear what that sounds like. I'm gonna toss my headphones on so I can actually hear it. Okay. Let's see, let's drag this in. So there we go. We have two brand new instruments that are created. I'm going to make this easier to look at real quick. Kind of blow it up for people watching, maybe on their phones. Cool. So now we have this song. One thing to note, the BPM is going to be really fast. It's set to 120. My program does set the BPM, but sometimes Logic just ignores it if you drag it in. Just something to keep in mind. So it'll be pretty fast. But what we have here is we have two tracks. Let me pull up the piano roll for this track. Let me zoom in a little bit. So the one on the top should be the left hand, the one on the bottom should be the right hand. I'm going to label these to make it easier. Left hand and right hand. So let's start with the left hand. So what do we have for the left hand? Well, let's do this. I'm going to highlight this section. These are 4 bars, because like I said, a section is 8 bars, but 4 bars are going to repeat for the left hand. So let's just zoom in on that, and we can see what this looks like. So we can see, okay, the first pattern is here, this section right here. So we have what looks like a 1, 5, 8, 5 pattern. Right here, we just have a single note that lasts the entire duration of the bar, so that's a 1 pattern. Right here we have that's a 1-8 pattern, that's just an octave, a half note of 1 and a half note of 8, and then looks like a 1-5-8. So if we solo out this track and play it, here's what it sounds like. You can see once it repeats after 4, your brain already kind of expects it. It's pretty cool, like it's pretty neat. Let's move on to the right hand. So again, the right hand's gonna be slightly different. Let's solo out the right hand this time. The right hand's gonna be different because it's not a 4-bar pattern, it is an 8-bar pattern. So let's just extend this to 8, makes it easier to see and understand what's going on here. So you can see the notes kind of scrunch between like this. This seems to be the range of the notes. Again, all customizable by the program, but I just went with the defaults. So the right hand just has random notes like a 16th, an 8th, a quarter. I don't actually know if this is what these are, but you can see it's just been randomly generated to fit in this scale. So if we play the right hand, we're gonna get so yeah, I mean, it sounds like a Temple OS song. So, does that sound nice? The goal of this was to make nice, relaxing piano music. It sounds neat, but it kind of sounds like a mess. Doesn't sound like something you would listen to relax. So let's step back a little bit and let's play both the left hand and the right hand together and see what we have. Okay, kind of a mess, but kind of cool. I mean, a program wrote this, like that's pretty awesome. So let's do some movie magic on this. First thing I'm gonna do is I'm gonna replace the built-in Logic piano sampler with a piano library that I've purchased. It's gonna sound way better. So what I like to do is I like to turn off all these built-in effects that come with it. We go to the contact player and we'll grab, we'll do Noir. This is a really awesome piano library. I'm a big fan of Noir. Cool. We don't need to get fancy with it, so let's just use one of the presets. We'll just reach for emotional. Sounds good. Then we'll do that to the left hand and the right hand. What I'm going to do is I'm going to cheat a little bit here. I'm just going to open up the mixer for the left hand and the right hand. I can see the left hand's here and the right hand's here. I'm going to turn off all the effects on the right hand and then just copy that over. So now they both have the same effect. So I just know from experience it's going to be a little bit quieter, so I'm just going to preemptively boost this, but I will set it back and we'll do some work. So here's what it would sound like now. Okay, pretty cool, but still kind of meandering and just doesn't really make much sense. So I'm going to show you what I did to make that video, that 5-hour generated algorithmically, whatever, piano, etc. I'm going to show you the techniques that I took. So first things first, 120, too fast. We're going to cut that right in half. 60 BPM. The song is now half as fast, and it's going to sound so boring. So let's do a lot of preemptive work on this. I am going to take these two tracks. Oh man, that is not what I wanted. Okay, we're going to create a track stack. This sort of, it acts like a folder, but on top of being a folder, it sort of creates a bus under the hood, and I can put effects on the stack. So basically any effect I put on this will affect the left hand and the right hand. This is convenient because I can just toss on, let's say, a really simple compressor. I'm not going to get too deep into the mixing and mastering here. It's outside of the scope of this video, but we'll put a basic compressor on, and then we'll throw on a nice little reverb. I like Valhalla Shimmer a lot. Put a concert hall reverb on. Let's put it like 30 maybe, and then I mean, we technically could compress it again. Well, let's not get too fancy. Let's just hear what this sounds like now. Let me boost the volume just a little bit, put a limiter on it. So here's what we have now. Pretty cool. That little thing at the beginning was just the reverb. It's just, that wouldn't be part of it if I exported it. Pretty cool. So once it hits here, it's going to go into the next section, the B section. You can hear it's different, but it started at the root. Every new section always starts at the root to kind of ground you in that. So yeah, there you go. It's a very relaxing style piano music. And this is basically the gist of what I did for that video. But you are free to do whatever you want to this. You could make this sound wild. For instance, I could take this right hand and I could change the plugin that it's using. All right, so you can get crazy with this. Let's say I'm using the Piano Colors plugin, put this on the right hand. You could kind of get some wild sounds. Like, there's really no rules to what you can do with this. So you can see, I mean, real quick you can see it kind of gets a little bit crazy, but it's awesome. So I'm not doing anything particularly fancy, I'm just going through the built-in presets. I mean, there's really no limit to what you could do. You could make these synth sounds, you could make these melodies into like a trance song if you wanted to. 60 BPM seemed to work for me, but I mean, you could jack it up if you wanted to. Kind of sounds like a mess. I'm going back to 60. You are free to do whatever you want here. You can get crazy with it. You could throw, you know, remix stuff on here. If you wanted to. Yeah, I mean, you're free to do whatever you wanted to this. You could make it sound lo-fi if you wanted to. Put a nice little beat over this and got a really eerie piano lo-fi track. I don't know, I mean, do whatever you want. So yeah, that's basically it. That's the entire process I went through. All the code's available online. Hopefully this deep dive was helpful. Hopefully it was enjoyable. Again, if you like what you saw, feel free to like, comment, subscribe, do whatever you want to do. So yeah, thank you for watching. If you enjoyed this style of content, let me know, because I normally just upload music to this, but it'd be fun to do more like talking to the camera style of content. I actually find it kind of enjoyable. Take care, everyone. Make sure to buy my merch just in time for the holidays. What's up? All right, see you, everyone. I haven't looked in this code in like 2 months. I actually don't remember how this works. Oh, make melody. There's a make melody function. The hell does that do?